Hello guys and gals, we are going to be talking today about solving a quadratic equation using a square root rather than factoring. So there's two ways that we can solve quadratic equations. We have to factor when we've been given an x squared term and an x term, and then if we only have an x squared term, we can solve the equation by taking the square root. So what you're going to need today are your notes, maybe a calculator, a pen or pencil, and the foldable that I printed for you. There's two different types of equations. When we have just a 3x plus 4 equal to 16 versus a 3x squared plus 4 equal to 16. They're similar, but the difference is the first one has an x in it and the second one has an x squared in it. And the x squared is going to change how we perform the final steps in solving. And it also gives us a clue about how many solutions there are. Remember the fundamental theorem of algebra. The largest exponent will tell you how many solutions there are. So the fact that this is an x squared is telling me that there's two solutions, where since this is just an x to the first, there's only one solution. Okay? So when are we going to know how we need to factor and when we need to solve by taking the square root? The equation will tell you what it needs. So in this first example, we have x squared minus x minus 6 is equal to 0. When we have two x's, or an x squared term and an x term, we have x located in two spots and we can't combine them. That means that we're going to have to factor, because there's no way that we can isolate just the x and solve, or just the x squared and solve. There's no way that we can do that. So we would have to solve this one by factoring. You'd have to set up your two sets of parentheses, equals 0, x here, factors of 6 that get back to a negative 1x is minus 3 and plus 2. So then you would have an answer of x is equal to 3 and x is equal to a negative 2. That's the speed version of how we would factor. Whereas if you just have in your equation an x squared term with no other x's or no other variables in it, you can solve by getting him isolated. So you'd have x squared minus 6 equal to 0, add 6 to both sides, you're left with x squared equal to 6, and you'd have to take the square root in order to get the squared away, and then you know that x has to be plus or minus the square root of 6. Whenever you take the square root when you solve or when you have an equation, you're always going to have the positive version of it or the negative version of it, and we can talk more about that in class if you have questions on why you don't remember that's the case. So solve by taking the square root is what we are doing today. And let's link this back to the most recent thing you've probably done. Back in geometry, you guys, you did this. You did solve by the square root when you did Pythagorean theorem every single time. You knew 6 squared was 36. You knew 10 squared was 100, brought down the x squared. You subtracted 36 from both sides. You took x squared is equal to 64, and then you took the square root and the square root, and you got back x is equal to a plus or minus 8. And that's what you did. And in the context of a triangle, you knew that it only had to be a positive 8 because we were talking about distance. Okay, so we're going to be doing these kinds of equations now, and we're going to go through 5 examples. Okay, so the first example, we have 3x squared plus 5 is equal to 41. So just isolate x like an x squared just like you would an x. So minus 5, we're left with 3x squared is equal to 41 minus 5 gives us a 36. Divide both sides by 3. 3 divided by 3 just gives me 1, so you're left with x squared is equal to 36 divided by 3 is 12. We need to take the square root of both sides so we can get rid of that x squared or the squared on that x. And now we need to simplify the square root of 12. Well, we know that 12 has a factor of a perfect square, that's a factor of 4, and this the other factor would be 3, because 4 times 3 gets me back to 12. So x is equal to plus or minus the square root of 4 times the square root of 3, and we know that we can simplify that square root of 4 into 2 square roots of 3. So we definitely need to put the plus or minus on it, because remember the x squared tells me that I have two solutions. I have two of them. So if I plugged in a positive 2 times the square root of 3 back into here, I would get an answer equal to the same answer. My equation would hold true, and it would do the same if I plugged in negative 2 times the square root of 3. Okay, so for all of our answers today, we're going to need this plus or minus sign out in front of our answers because we need to have two solutions when we're solving for x squared. Let's look at example 2. So solve for x, get x squared isolated. So in order to do that, we need to add 15 to both sides before we divide by 2. 2x squared is equal to a negative 50. Now divide by 2, divide by 2. You're left with x squared is equal to a negative 25. In order to get the square root away, we need to square root both sides. That cancels. You're left with x is equal to plus or minus. Remember what we did in the most recent video before this one? We learned the imaginary numbers, right? The square root of negative 25 is going to get me the square root of a negative 1 and the square root of 25. And we know the square root of 25 is 5 and the square root of negative 1 is I. So my final answer is plus or minus 5i. Number 3. 3x squared minus 5 is equal to negative x squared plus 9. Now we have an x squared term on the left side of our equation and on the right side of our equation. So what we need to do is get all of those x squared terms to one side. So I'm just going to add x squared to the other side. So I'm left with 4x squared minus 5 is equal to 9. Now we solve like normal, so add 5 to both sides. We're left with 4x squared is equal to 14. Divide both sides by 4. We know that 14 divided by 4 is not going to give me a clean number or a whole number. So let's reduce the fraction. We can take a 2 out of the top and the bottom. So that reduces down to 7 over 2. 14 divided by 2 is 7. 4 divided by 2 is 2. Okay, now we take the square root. So we have x is equal to plus or minus the square root of 7 halves. And that would be my final answer. You guys can leave it like that, or you can rationalize the denominator. I don't care. If you have questions about rationalizing the denominator, you can ask me in class. Example number 4. This one's set up a little differently. So we have x plus 9 squared. That whole quantity or that whole expression is getting squared, and that's getting set equal to negative 4. So in order to subtract the 9, we have to get rid of that squared or that 2 before we do anything with the x or the 9 in the set of parentheses. So what I have to do is I actually have to take the square root of both sides first to get rid of this guy. So now I'm left with x plus 9 on the left, and I have the square root of a negative 4, and I know that that's going to break up into the square root of negative 1 and the square root of 4, and we know that the square root of 4 is 2, and the square root of negative 1 is I. So now, and that's plus or minus 2i because we took the square root. Sorry, I almost forgot that. Now in order to solve for x, I have to subtract 9 to both sides. So that cancels here, and I get x is equal to, we have plus or minus 2i minus 9, but remember with these complex numbers, you want to write, sorry, I'll write that this is a complex number. You want to write the real part first and the imaginary part second. So we need the negative 9 out in front, plus or minus 2i. You guys can leave your answers like this, negative 9 plus or minus 2i, or you could give me them separated as negative 9 plus 2i, and my second solution is negative 9 minus 2i. It doesn't matter. You can do this, or I'll take the other one, x plus, or negative 9 plus 2i, and x is equal to negative 9 minus 2i. Either way, I don't care. I know that they're the same answer. And number 5, holy cow, there's a lot going on in this one. So we're going to have to make sure we're diligent in doing the steps in the correct order, or else we're going to mess up and not get the right answer for x. So when you see an equation like this, where x is inside a set of parentheses getting squared and there's a bunch of other crap happening to it, okay, we need to get this parentheses x plus 9 squared alone first. That's my first goal. So I'm going to add 1 to both sides. So I have 3 times x plus 9 squared is equal to 40. Now, before I take the square root, I need to divide by 3 on both sides. So that can cancel or equal 1. So I'm left with x plus 9. That whole expression's getting squared, and it's equal to 40 divided by 3. Now I can take the square root to get rid of it to get rid of that squared on the left side. So I have x plus 9 is equal to plus or minus the square root of 40 over 3. And now the last thing that I need to do is subtract the 9 from the other side. So I have x is equal to negative 9 plus or minus the square root of 40 over 3. And that, ladies and gentlemen, is my final answer. Make sure when you do this, just like imaginary numbers where you want the real number to come first and the imaginary to come second, it's more proper for you to put the whole numbers first and the square root second. So we would say negative 9 plus or minus the square root of 40 over 3. Okay, so that is all that I have for you. Thank you so much for taking such good notes. I hope you get these 5 examples in your foldable, and if you guys have any questions whatsoever, please know that we can talk about them when I see you next.